Hello, everyone. Good morning, good afternoon, good evening, wherever you are, or whenever you are watching this recording. In this session, we will be talking about SRv6, which is segment routing v6, a emerging technology and choice of transport for 5G. This is our zeroth session on SRv6. Why zero? Because one, that it will be a series of sessions that you will see on SRv6, where we will be covering right from what the technology is, what are the best practices or the design guidelines around it, how you should implement it. And the second is that in this uh, session, we will be taking a step back and talking about IPv6. We will cover some of the unique aspects of IPv6, my learning about IPv6 that I will share with you, and then we will connect the IPv6 dots to SRv6, and towards the end, we will cover in the layman's perspective what SRv6 is. So this session is for the beginners or the people who are there for 3 to 4 years. But since we are talking about some key field learning about IPv6 as well, so even the experienced user can find it useful as well. So with that, what we will be looking at today as a agenda item is business reasons for behind moving to IPv6. I will not be talking about any of the nitty gritty technical details of IPv6 that can be parked for some other session. But in this, I will be looking at IPv6 from the business reasons. And why business reasons? We will cover in the next slide. Then we will be talking about IPv4 to IPv6. Is it just a bigger address space? Like IPv4 is your 32-bit to IPv6, which is your 128-bit, or there is more to it that we will figure out. And then towards the end, we will talk about our topic segment routing v6, what it is, and probably when we are covering these 2 points, you will be able to understand the reason why we are going with segment routing v6. So why consider IPv6? And there is no content on this slide. This is just we will be doing some whiteboarding. So I was fortunate enough to be a part of some of the discussions with a wide range of enterprises, large enterprises, mid enterprises, or even some smaller enterprises as well. And whenever we talk about IPv6, it starts with some objections. I remember there was a one session with a enterprise where there were, I think, 6 to 8 people in the room, and we were talking about IPv6. I was actually asked to present on IPv6, and I started with a slide where I showed some stats at that time. This was around 6 to 7 years back of IPv4 was running out of space, and these RIRs, which are registries for allocating the IPv4 addresses, are running out of space. They are saying that you should move to IPv6 or plan some other ways, but they don't have new blocks. And even in the aftermarket, if you see, IPv4 was getting expensive. But soon after, like when I was into this presentation for like 4 to 5 minutes only, there was some objections started coming in. And one of them was from the business leader, He highlighted that Sunil, whatever you are presenting is good. IPv6 looks promising, but you are telling me to fix something which is not even broken in my organization as of now. I couldn't immediately connect with what he was saying, but then there was another objection from a technical person. He says that you are saying that we should move out of NAT. NAT is nothing but your network address translation, which can translate your V4 address, which is private, to public. We should get rid of it. But don't you think that this actually provide us a shield, a kind of a security shield? So I took a pause and then I started thinking from their side, and both of them were right. What I was talking about is this IPv4 scarcity. World is running out of IPv4 addresses, but this is the problem that enterprise was not hitting because they were doing good with their IPv4 addresses, which were private, and they were using NAT with the help of their service provider. So all of their operations, all of their applications were running fine. So I took a step back and then did some back studies on this. So then I found that both of them were right. The problem is that how we were, or initially when IPv6 came out, this scarcity feeling was created that IPv4, soon the world will run out, let's move to IPv6. Even I remember somewhere in 2012, there was this IPv6 day that was called out by Internet Society, I think. And there was a lot of encouragement was happening for IPv6. But still, the world was not moving to IPv6 at that pace, or especially the enterprise segment, they were not moving to IPv6. And when I say enterprise is not moving to IPv6, I'm not talking about Amazon, or I'm not talking about Twitter or these big set of enterprises. I'm talking about the rest 95 or 98% of the enterprises. Even in 2023, we have the discussions with enterprises that you should consider your move to IPv6. So clearly, it was very evident that the scarcity was not able to sell IPv6 that much. And there was another aspect of it that I will give you for looking at this is that when suddenly uh, the RIRs were started running out of V4 addresses, there were these vendors and SPs started facing the pressure to keep the internet alive. And what they came up with is the development of NAT. And being worked on the vendor organization, I can clearly see that the amount of investment that had gone in developing the NAT, it's all features. And then for SPs to put some boxes dedicated for carrier grade NAT or 624 NAT, the investment was huge. But all these investment, enterprises were not involved. Now they may be paying a piece of it, but it was all happening a bit away from them, and they were not even bothered about it, like what is happening on their side. So That's where the slower adoption of IPv6 happens. And to conclude this discussion, if I look at this IPv6, the first draft for RFC, which was, I think it was 1998, that no, came in, no, sorry, the draft was 2460 and it came in 1998. And if I look at another example, which is MPLS, the RFC which I was initially reading on was 3031 back in the time. It came in somewhere 2001. But I'm not talking about anyone else. Those are the trends. But if I just look at me, I was deploying MPLS for a SP in 2007, right after the college where I got this opportunity to work and deploy MPLS. But even in 2023, we are having discussions with enterprises for the adoption of IPv6. So you see one technology versus the other, why the adoption of one was so high that even tier 4 SPs were using MPLS, and now even SPs have moved and they are looking at migration to MPLS or SRv6 that we will be looking at in our subsequent session. But IPv6, which came before, was still not that widely deployed if we leave some of the outliers. What was missing in these? Clearly, the business drivers. Where for MPLS, it was quite evident. The business drivers were clear. Technology adoptions happened so fast. But for IPv6, initially it was the feeling of that scarcity, which didn't went well, and it saw that lower adoption. Now, if I'm not wrong, even today, Google sees, I think, somewhere around 35 to 40% of their traffic on IPv6. So still IPv4 is competing hard. It is still there. I can put some link in the description to validate these thoughts. So, but our title says, why consider IPv6? There has to be a business impact for that. And I will cover just two examples from our discussions and then we will come back to our story. So let me clear this ink here and then some of the business drivers for IPv6. So there was this enterprise that I was talking to. I was pulled into this discussion where it was an online retailer and this business had started booming at that time. It was 2016 or 17 time frame. We were all part of this meeting where their application architect had started showcasing us a analytical tool. What it was doing is it was capturing some stats, like from where the traffic is hitting on their website. And this guy was highlighting a problem that what he sees is only a pool of addresses, repeated traffic from these pool of addresses, and he wanted to check with the networking team, is there anything which is broken into this? Coming from the networking background, I was also working with their vendor as well, or like the service provider who was providing connectivity to them. I knew that their SP is using carrier grade net. And again, I'm not going into the nitty gritty details. That time it was an in-depth study that we had done, but this is just an example at a 30,000 feet that I'm just telling you the business reasons. So for them, the NAT was clearly breaking this application. And that's how we started the IPv6 discussions with them. So there was this business drivers that had led into the discussion for IPv6 and later on the implementation as well. What is the other example? So example number two is, and this is more interesting by the way. So I was part of a meeting for a banking customer where there was this business leader was talking about a problem, and the problem was of too much security. So we didn't understand and asked some more details. So he said that uh, they had introduced some new features in their net banking at that time where they had prompted their users for some security questions to make sure their real identity. And whenever, so the system was designed in such a way that whenever they log in from a new system, they will be prompted with these questions so that just to make sure that they are the real users. But then he told that their call center is flooded with complaints that these days their users are seeing these questions more often and they end up wasting time on this. Why there are like so much of security that you guys are pushing? And on top of that, there was a disclaimer on their website, some message that it seems that you are using a new system, so we want to make sure your real identity. Whereas their users were saying that it is same, we are using the same system, so why you are saying that it's a new system? Till this point, I thought that the problem is somewhere at the application layer, but then they started showing some real-time captures, and that's where I was able to see that there were some addresses that were repeated for different users, and this problem was also happening because of NAT, which their SP was using, the config, the type of config that it was using at that time for CGN. So again, this is very highly simplified version of this problem, but the point is not to go into the technical side of it. The only thing to know is that the NAT was causing the issue here, and then there were discussions initiated for IPv6. So you now see that there are some real reasons, there are some applications which doesn't function fully or doesn't perform the way it is if there is no end-to-end IP connectivity. So to come back to our story, so for any technology adoption, as I was giving you the example of IPv4 to V6 or to MPLS, in one part, business reasons were quite clear, so the technology adoption happened so fast. So there has to be a business reasons for a technology to be adopted. And one key learning from these 20 minutes of discussions that I want to share with you. Normally, people ask such finicky questions where, like, Sunil, what you will do if you were go back 5 years or 10 years before? Of course, there will be more things to do, but one key learning that I would suggest is that if you are a beginner or somewhere at intermediate stage of your career, always figure out the business drivers for the technology that you are implementing. When I started my networking career somewhere around 2007, I was so deep for the next few years into the technology side of it, I didn't even look at the business side. I will share some more examples of this in the upcoming slide, but this will be a humble advice that whenever you are working on any new technology or even the existing one where your enterprise or service provider or data center, or simply call it your organization, is investing, figure out the reason from the business side. So with this discussion, we had seen that, okay, there were some reasons for the business, and even there are more now with this IoT world where a lot of sensors are being connected onto the network to fulfill some business aspect of it. And these all need an infrastructure to support, and that's where we need more IP addresses. So when IPv4 was designed, we had very limited number of endpoints type. So IPv4 came somewhere around 1980s or so. But now there are more and more number of endpoints being introduced every day, and they all need IP addresses. So that's where the IPv6 is needed. We already talked about this second bullet where it opens the door to the new services like analytics, legal interception, security, and IPv6, since you have so many addresses, it can have multiple IP addresses on the same device so that that endpoint can be connected to multiple networks simultaneously. That is needed for some seamless mobility use cases or some other applications that may need it. So I hope by now I was able to give you some aspect on the business side of IPv6, not necessarily just talking about IPv4 is running out of space. So enterprises will have advantage over IPv6. It's just that some of them had uncovered the reason to move to IPv6. Others are in the process of doing that. So that's where we will shift our gear now, uh, and we will see one more interesting angle or one more thing. Like we so far focused on the business side of it, but is there anything more? Or if I look at our second bullet item, if you remember, is it just a bigger IP address for IPv6? Or is there anything more to it? So let's just understand this from a very simple analogy. There was this friend of mine who was having this hatchback car actually. And this guy Jess was, his name was Jaswinder. He was very fond of driving the car like many of you may be. And when he bought his hatchback, he always wanted something extra. So he installed some headlights into this, which were like very bright. Then they come by default that comes with the car. He changed the music system also. And after driving it for 4 5 years, he wanted to upgrade. So we went together and I asked him like, okay, now that you have a family as well, so you should move away from hatchback and you should look for sedan. And he said, Sunil, not only sedan, I need some features as well into this, where I have done all these ad hoc modifications that you see in the car. Now the companies itself are giving it, and on top of that, there are more features that they are giving it. So I was like, yes, that's amazing. So he considered something like this, the way hypothetical example. He went with hybrid, and whatever he had fitted in the aftermarket, he got it here. So why I told you this story? Now we are also having IPv4 in our domains already, and now we are moving to IPv6. So isn't it from a protocol perspective, or the inventors who have designed IPv6, they just thought that, okay, let's give a big address space to the audience. Will they be satisfied? Or there were some problems into IPv4, and that, like a hatchback, were fixed into the sedan version of IP, which is IPv6. So that is where, let's just look at some of the key aspects, or I would call it like the limitations of IPv4. So one that we had already seen, that it was a limited address space. So we introduced NAT so that IPv4 can survive for more time. And NAT is being used even today as we had seen it. But was there anything extra? So as I was saying that in 2007, I was working for an organization where we were deploying MPLS. And as a part of this, we were asked to deploy the VPNs for the customers. So I was working for a service provider organization where there were multiple customers for which we need to provision certain VPNs depending on their type. So for this, what was introduced is a MPLS VPN. So BGP, as I came to know, was enhanced for this to have VPN v4 address family, as if we are already having IPv4 address family, but this was not designed to carry the VPN prefixes. So BGP was enhanced so support VPN v4 address family. Then there was another protocol called LDP, whose job was to allocate labels to IPv4 destinations, because IPv4 was not that efficient even from the forwarding perspective if you compare it with labels. So labels were switched at the hardware much more efficiently than IPv4. So LDP was introduced. I was like, okay, we can run MPLS VPN forwarding based on labels. But then it happened that one day I was called, and we had one very special customer who wanted some special services. And being a service provider, there was some business reasons, as I was saying, we had to implement it. So what his ask was, his head office was in Delhi, and he needed direct pipe to Chennai, where his another site was there. So currently, the provider that I was working on, the path was from Delhi, you go to Mumbai, and then you come to Chennai. But we were provisioning a direct link from Delhi to Chennai. But here is the catch. Our management wanted that this Delhi to Chennai link for some time be only dedicated to this customer. Rest all customers, they should use this path only. So this, I was quick enough that, okay, this is something that can be done with IPv4. We will put some static route. So what this customer was asking is some sort of traffic engineering. And I was like, okay, we can put some static route. Till the time I came on the routers, logged in, and I saw that here the traffic is switched based on labels. It is not IPv4. I cannot put static routes for the labels. So we again went to ground zero and like, okay, how to meet this requirement? We checked further with the SMEs and then we were asked to implement RSVP based TEs. So there is a LSP. For those of you who don't know, it's a label switched path. So a LSP is configured and only this customer's traffic was moved to this LSP. And later on, we had couple of LSPs to meet these requirements. So even this RSVP, which started from one tunnel, ended up with so many tunnels that we had in our network. Then we slowly realized that our path within this MPLS domain were not efficiently utilized. There were some links which were more utilized, some links were less utilized. So there was no load balancing. We brainstormed internally, nothing was there. We checked with our vendor, and they said, go with entropy labels. So, entropy label is designed to load balance. I was like, as if RSVP or MPLS or the other stuff that we had done already was not enough. You are saying we should go with this. But till this point, I was okay. But then there was a requirement for a source routing. So this I already knew that, okay, source routing we can implement with the help of PBR. But the problem with PBR is you need to implement PBR at every hop. Let's say if R1, R2, R3, you have three devices, you want to have some sort of PBR, you need to implement on all three. And in my domain I was working on, the packets were labels and there is no PBR for the labels. So PBR was not an option. So I was advised that, okay, go with segment routing based TEs. By this time, I was like, we started with IPv4, wanted to give some IPv4 end-to-end services to our customer, but we have implemented so much of things in our domain already just to meet one or the other requirement. And not to mention, this was adding a lot of operational overhead on the engineers who were working for the day two operations. And suddenly, one day, what happened is there was an attack that happened on one of the server in the DC. So whole our pipe, the bandwidth, the uplink was choked, and we were figuring out why it is happening. The team was quick enough to identify the attack, but then it took a lot of time, even the L3 team, to mitigate that. So when we were able to mitigate the attack, I was happy with the team's performance and then reached out to my director saying that, sir, we have solved the problem. But he was not happy. He said, solving a problem, I knew you guys will do it for sure, even if it happens next time. What I want, Sunil, is make a business case out of it. I was awestruck at that time, like we solved the problem, but you are saying you are not happy. We need to have a business case. So he said that server belongs to a customer. It's hosted in our data center. So how can we make more out of it? And that's where the concept of service chaining evolved, where our security team said that if you can route this traffic somehow, the server traffic via the firewall, that way we can inspect the traffic. And later on, it was not just limited to firewall, load balancer also came into picture, IDS, IPS. There were so many devices that we need to take the path through. We were scratching our head how we will do it. Static routing was not at all a scalable option. So we came up with something called NSH, Network Service Header, to give this end-to-end service for IPv4, passing it via multiple hops. And again, I am oversimplifying this. So then I was like, okay, we have added like so much of complexity. End of the day, what we are providing to a customer is IPv4 service end to end. But to provide that, to meet those unique requirements, there were so many of these things that you see on the slide were added. So, is there a way to simplify? So, let me clear the ink. So, with IPv4, as you see, we have already talked, we have not talked about VXLAN. So, VXLAN, when was introduced when we run out of VLANs in the data center, we came to know about VXLAN. So, VXLAN was exactly solving that problem. So, you see so much of these because IPv4 was designed somewhere in 1980s, and that time it was expected to provide some sort of reliable connectivity between the two endpoints. But then customer business requirements have changed a lot, and then to meet those requirements, all these ad hoc concepts or inventions were done to meet those requirements. So you can call it like a workaround, but is there a way to get rid of it? Can we just simply like this, you see this cross, can we do this and provide this just over a IPv, not v4 maybe, but IP header? That's what the IPv6 was actually designed to, with these problems that we have listed down. So when the committee was drafting IPv6, they not only looked at that, okay, there has to be a sedan version of an IPv4 address space. It is not that just sedan. It is that sedan version of IP which Mr. Jaswinder was looking, where he was also looking for some more features for which he had gone to the aftermarket, did some fixes here and there, like he had fixed the headlight, music system, seat cover, the list just goes on. So that's what the IPv6 was designed, keeping all these thoughts into the mind. So now let's just look at this, or let's start our SRv6 discussion. But before that, just one step before on SRv6, and this is my final slide on IPv6. After that, we will move towards the SR side of it. So by looking at this, you can easily identify that this is IPv4 header and this is IPv6 header. Not to mention there are already a lot of content available that V4 to V6, the header sounds much simpler. There are very less fields. So, but I want to cover just one particular aspect of it, and we will connect our dot to the segment routing is, and it had also happened actually in one of the interview where I was given two systems. One of them was client, another one was server, which was running some HTTP services and some multimedia application. This was having IP of 10.10.10.2. This was having .1. So this interviewer asked me that, Sunil, if you are opening that multimedia application, that is one, and second, you are opening HTTP application, your both the traffic sourced from .1 will go here. How this guy server identify whether the traffic is coming from the HTTP application or the multimedia application when the source IP is same. So coming from the deep technical world, I was immediately answer these questions that there is this protocol field, which is nothing but just the port number. So it will use that port number to identify HTTP port number will be different and multimedia port number will be different. It's TCP based, let's say, or it is UDP based. That way, this server can identify. But coming back to our story, you don't see this protocol field in IPv6. What you see is the next header. And this is very important for our discussion on SRv6. And we will see how. For now, just hold the thought that there is something called as next header in IPv6. So now let's move from IPv6 to SR. And here again, I would like to give you one real life example of SR. So during that time in college, and most of you who are from India will relate that whenever there is a marriage function in India, we normally distribute sweets after the marriage. Now, when the guests come, we normally give it there itself. But earlier, there was a tradition that you give the sweets uh, to their home. After the marriage, you go to their home and you give the sweets. So, and this was my duty till the college time. Whenever my elders got married, my father used to give me a list that you take some boxes of sweets and deliver to Mohan, Ashok, Rohit. Like there was the list that used to go on. And he used to tell that follow this list. I was like, okay, we'll do that. So we used to take a bike with my friend on the back, holding all those sweet boxes. We go and then we reach to Mohan uncle's house. We give the sweet. Then we go to Ashok uncle and we give the sweet. And then one time it happened that uh, Gopal's house was actually closer to Ashok. So we thought of delivering it to Gopal's first so that we can save some time. So from here, we directly went here and delivered the sweet. And not sure it was just a coincidence or our bad luck or whatever. The bike ran out of fuel after that. And we couldn't deliver the boxes to Rohit Mishra's house and Chandar's house. I came home and we thought that, okay, on the next day we will deliver because it was already sunset. But in the evening, my father got a call and then he immediately called me that you delivered the box to Gopal first and you haven't delivered to Rohit. By the way, Rohit was the elder brother of Gopal. So we need to follow that hierarchy. And my father was like very strict on this that we should deliver to the elder brother's house first and then we go to the younger one. And he told that I given you the list, why you haven't followed it. So this was like a shock. I apologized and then I said that will not do it again. And from next time onwards, I was completely following the list. But how can we relate this to our discussion? I was given this routing list, the path that I need to follow at my home itself, which is the source. And I need to follow exactly this list holding it in my hand. So can we do something like this with IP addresses? Like when the packet is coming from the source, you have somehow the list given to it so that that IP packet itself follow that path on the journey. Let me give you another example for maybe the international audience, so whoever is watching. On a flight, you see your baggage, right? On baggage, you see a list which says SFO, then maybe CDG, which is Paris, then maybe Mumbai, and then Bangalore. So this is the path, let's say, you are taking. So while you are changing your flight, let's say you started from San Francisco, you came to the Paris airport, which is CDG, you come out of that flight, go to the boarding gate of your next flight, which will be to Mumbai, your baggage also change. So what this baggage handler do, he look at that okay, it's coming from SFO, now it is in CDG, it need to go to Mumbai, so he will simply put that onto the Mumbai flight. When the flight lands on Mumbai, he will simply do that to the Bangalore flight. So that baggage itself have that information for that baggage handler to figure out where it need to put. In our analogy, the IP packet itself have that information where it need to go and which path it need to follow basically. So this is actually the same example but with different airport, but I hope you got this. So this is your segment routing basically. So with segment routing, we have something called as control plane and data plane. We will cover these in our upcoming session, but for now, from the data plane perspective, there are two mediums that are supported. One is IPv6, another one is MPLS. So in MPLS, you have just one label with one segment. And if there are multiple segments, you will have a label stack, like multiple labels. For example, if my path is R1, R2, R5, let's say, and then we have R3 and R4 somewhere in between. This is, let's say, label 10, this is 20, and this is 30. I can put the label stack something like this. Again, I'm oversimplifying it. We will look at this in much simpler way. So just by looking at the labels, I can see that, okay, I need to go to 10, which is R1, then 20, which is R2, and then 30, which is R5. Between R2 to R5, since nothing is mentioned, I have that choice of choosing any path from R3 or R4. But don't worry, if this is something new to you, we will cover this. It is just the zeroth session, as I was saying earlier, just an introduction. We will open up these concepts more. But for and same goes for IPv6, where your one segment is one address. If you want to like move between multiple routers, or let's say multiple hops that you want to specify, you give those address list in the SRH. What is SRH? It is segment routing header. So this SRH comes in that next header. When you see that next header field, if you recall from our previous discussion, what I do is, if I quickly go back, I will add the headers here. And in this next header, I will say that there is more routing that you need to do, and check the next header. So it will say IP address 1, then IP address 2, and so that it follow the path R1, R2, R3, like that. Understand this with an example where on the source itself, I want to move my traffic from R1 to R2 and then R3. With the next header explanation that I given, how I will make my IPv6 header is something like this, where I will have my header is, this is R1 address, this is R2, and this is R3. Since the packet is starting from the source, R1 is my first destination, so I will put that here. Now between S and R1, there can be many hops, which I don't care, because my first hop, as per the list that I had received, is R1. So I need to go on R1. Once I reach on R1, I would now need to go to R2. So I will put this here, and then we'll follow the simple routing. There is no RSVP, there is no other fancy protocol, simple IPv6 routing that I will follow the path till R2. Once I reach on R2, I will move to R3 by changing the destination address in my header. So you see how segment routing with IPv6, the native IPv6 routing itself is achieving this traffic engineering. In this R2, let's say, can be somewhere here, which is a firewall, right? So my traffic will pass via this and then come via this. So I am achieving that requirement of NSH, service chaining, right? Likewise, we will look at how SRv6 is simplifying the network, how we can get rid of the services that I had shown on that IPv4 limitation slide. We will cover in our next session. So we are concluding this session now. Thank you very much for listening in. I hope this is something that was informative for you. Any feedback, just let me know. And I would like to see you in our next session. Thank you.